Section 2.5 Measures of Position. Let's begin this section by talking about quartiles. If we were to list all the data in ascending order, we can split it into even sections called fractiles. One type of fractile is quartiles. Quartiles, and this is when we split up our data, not split up, our data list into 4 even parts. Note that the data needs to be listed from lowest to highest. So this is saying we can take our data, and if this is all of our data, I can split it into half, which would be our median, and then split our half into a half. And this will give us quartiles. These quartiles would be quartile 1, quartile 2, which is also our median, and quartile 3. Definition of quartiles. The 3 quartiles, Q1, Q2, and Q3, divide our ordered data into 4 equal parts. About 1/4 of the data fall on or below the first quartile 1. About half of the data fall on or below the second quartile. And the second quartile is the same as the median of the data set. About 3/4 of the data fall on or below the third quartile, quartile 3. Example 1. Each year in the U.S., automobile commuters waste fuel due to traffic congestion. The amounts in gallon per year of fuel wasted by commuters in the 15 largest U.S. urban areas are listed. Find the quartiles. All right, so if we were to do this by hand, we would go ahead, list all the numbers from lowest to highest. But we're not going to do that by hand, because what if you have a large amount of data? If so, I'm going to tell you the answers, but I'm going to tell you the steps to using your calculator. So use your calculator, or if you're using Excel, use Excel. So your answer for this question is, well, I don't have this one. You can figure this out on your own. So to use your calculator, you're going to start doing your list like you would for any problem. So, well, for any problem with raw data. So 1, you're going to go to the table, find your table by pressing Stat and then Enter, and enter all the information in L1. 2, exit the table by pressing Second Mode, and this allows you to quit your table. 3, press Stats, and then use the right arrow to highlight the second command that reads Calc, and press Enter to choose one of our stats. 2, choose your stored list L1 by pressing second and then the number 1 and then enter. You should have all the list of information, but quartiles, that's found at the bottom. So then you use the down arrow and scroll down a lot, and then you'll get what's called your 5-number summary, and that includes your minimum, your Q1, your Q2. I think you'll write it as your median, Q3, and then your max. So then you can easily find your quartiles. Now, if you're using Excel, you're going to type in all your numbers in Excel, and you're going to start typing the command quartile inc. And usually when you start typing in Excel, it starts bringing up the command. So maybe once you're like the 4th or 3rd letter in, you'll see that command pop up. You choose it, and then you're going to highlight your numbers so that you want your first and your last, but you find that by highlighting. And then here, you enter what quartile you want. And that's how you do it in Excel. I'll post the video along with this page so you can access that. Example 2, same idea, give this a try and use technology. Do not try doing this by hand. Just so you can check it, your quartile 1 should be 28.5, quartile 2, 36, and quartile 3, I'll leave that for you. I didn't write that one down. We also have to deal with interquartile range, IQR. The interquartile range of a data set is a measure of variation that gives a range of middle portion about half of the data. The IQR is the difference between the third and the first quartiles. So your RQR is Q3 minus Q1. Make sure you highlight that so you remember, you find that easily. All right, the IQR helps identify if there are any outliers in our data. Outliers are found when the data value is less than 1 times 1.5 times IQR, or our data is more than Q3 plus 1.5 times the IQR. So this is to help you find outliers. So if there are any lower outliers or any higher outliers. We also use quartiles when creating a box and whisker plot. This type of data or this type of graph is helpful because it highlights important features and also gives you an idea of whether your data is skewed in any way. Follow the guidelines from page 105 and see image below. So I really like this picture, so I kept it as is from your textbook because it tells you how to find it. You want to find your first 5-number summary, which is made up of your minimum, Q1, Q2, and Q3, along with your maximum. So it's just your lowest and your highest number, min and max. And then we're going to create a horizontal number line where we have all the numbers that we'll work with. You want to plot your 5 numbers on a horizontal scale, and then you want to draw a box above the horizontal line, and you want to label your Q1, Q3, and draw a vertical line on the box at Q2. Draw the whiskers from the box to the minimum and maximum values. So you're going to have a number line with all your numbers that you work with, and then you draw a box and whiskers right above, labeling all these key points. Your minimum, your Q1, Q2, Q3, and your maximum. And then you draw a line connecting the middle box to your lower and highest values. All right, and I like this because I think once we see just a general rule of it as a picture, since it will be a picture, it helps us kind of see what we should be doing. Okay, let's do an example. Draw a box and whisker that represents example 1. Hint, you already found the values. All right, so from example 1, you should have gotten, so back to example 1, you should have gotten 11, 23, just kidding. Q1 is 23, Q2 is 25, Q3 is 30. So back to our current page, we need those pieces. So Q1 is 23, Q2 is 25, and Q3 is 30. We also need the lowest number in our list. The minimum, the smallest number in our list is 11, and the maximum, the highest number on our list, was 35. And this is referring to the list from example 1 about the U.S. automobile commuter waste fuel. Okay, so I see that everything ranges from numbers 11 to 35. Let's draw a number line from numbers 11 to 35. So we need 11. How about I go, and I'm going from 11 to 35. How about I go by fives? That was a mouthful. All right, so we have 5, 10, 15, 20, 25, 30, 35, 40. Okay, cool. Now we have our graph. Okay, now I need to label these pieces. I need to label my Q1 and Q2 and Q3. My Q1 is 23. It's probably around here. My Q2 is 25. And my Q3 is 35. It's 30. And I like to write the numbers above so you can see exactly what we're talking about. And then I need to label my lowest and highest number. Those are going to be my whiskers. So I have 11. I connect it to my box. And then 35. And I connect it to my box. There we have it. We have a box and whiskers. Moving forward. Now this is a super important, super duper important concept. It doesn't go away. And yes, you will see this on a quiz, on exam, repeatedly. So you have been given a huge warning. The standard score. This is how we measure the number of standard deviations away from the mean. Recall from the last section when we learned about the empirical rule, where the number of standard deviations can tell us the percent the data falls under. The empirical rule limits us to standard deviations being whole numbers, 0, 1, 2, and 3, and negative 1, negative 2, negative 3. But what if the number of the standard deviation is not a whole number, but rather a decimal? Or if the number of standard deviations is more than 3, right? That is not covered by the empirical rule. Well, there is a way to measure such cases, and we use what's called a z-score. Definition of z-score. The standard score or z-score represents the number of standard deviations a value x lies from the mean. To find the z-score for a value, use the formula. So it's z equals x minus mu over standard deviation. To help you out, I also wrote it in words. The value minus your average divided by your standard deviation. Now here's just some wording to help you label something as probable or not. So if something falls between 0 to 1 standard deviation, it's normal. 2 standard deviations, not normal. It's pretty unusual. More than 2, 3 or negative 3, it's very unusual. Okay, so again, your z-score is your number of standard deviations, but it allows for decimals. Example 7. The mean spread of vehicles along a stretch of highway is 56 miles per hour, with a standard deviation of 4 miles per hour. You measure the speed of 3 cars traveling along this stretch of highway at 62 miles per hour, 47 miles per hour, and 56 miles per hour. Find the z-score that corresponds to each speed. Assume the distribution of speed is approximately bell-shaped. Okay, great. So we want to compare everything through a bell-shaped curve and find the number of z-scores, right? Negative 1, negative 2, 1, 2, 3. We don't know what we're working with, and we want to find that value. So we find the z-score that tells us the number of standard deviations. Now, word problems require a lot of reading, so if you'd like to take a moment to pause the video, make sure you understand what's going on. Okay, so when you're working with these scores, you want the mean and the standard deviation. You're also going to be given an extra number to compare it to. Okay, so let's label these pieces. These pieces are important. What is our mean? And what is our standard deviation? Our sigma. Okay, so the mean spread of vehicles along a stretch of highway is 56 miles, with a standard deviation of 4. Okay, there we have it. Now we're given numbers to compare it to, right? We have 3 cars we want to test out at 62, 47, and 56 miles per hour. Okay, we're going to have to work this out by using our formula 3 times. So here we have it. We have x minus mu divided by our sigma. And we have everything labeled, right? We have our mean, our sigma, and our x, those values, those other values we're going to compare it to. Let's write this out. So let's find the z-score. Z is equal to, let's do the first one, 62. So I have x for 62 minus my mean. Where's my mean? That's 56. Divided by my sigma, 4. All right, we use our calculator. We get 1.5. We just punch it in. 62 minus 56. Get your answer, enter, and then divide by 4. We get 1.5. So what does this mean? That this is 1.5 standard deviations above the mean. That's all that means. We're talking about standard deviations. See. All right, 47. Minus my average, my mean, 56, divided by my standard deviation, my sigma, 4. This gives us negative 2.25. Now, when I say positive and negative, it's just a direction. So a negative would be 2.25 standard deviations to the left or below the mean. And one more. Z is equal to third one. So we did 47. Next one is 56. 56 minus 56 divided by 4. All right, we get 0. So what does this mean? Remember the middle value, 0 standard deviations, that's always your mean. So it is equal to the mean. There you go. So this is z-scores. Now before you leave, write yourself in your own words, what is a z-score? I'm forcing you to look at the definition again because this concept never goes away. I don't want you to go through the remainder of the class not knowing what a z-score is. A z-score is the number of standard deviations from the mean. Okay, thank you for today. Have a nice day.